Hi, everybody. So today we will start 3.2. We are one letter behind schedule. Okay. This Friday you have homework 2 due and you have quiz 1. So your first quiz is gonna be about homework 1 and homework 2 stuff. Okay. The quiz will be in Blackboard. So you know here that's the homework, right? And then this is the quiz. So on Friday you'll be able to see the quiz 1 after the midnight, 12 a.m. Okay, then you have a whole day to start your quiz. So you click the quiz and begin. Then do you see this PDF? So you click the PDF, then you can see the quiz questions. And then you write down your answer on a piece of paper. After you finish, take a picture and then upload it here. Is that clear, everybody? Because it's only one page, you don't need to change to a PDF. Just English is okay. Right? And then submit. Okay? So I strongly recommend you use your laptop to open the quiz. Because I have students use the phone when they take the picture and go back, they get locked out. Okay? So use your laptop to start the quiz. And then you can take pictures and email yourself. And you download the picture in your laptop and then you upload it using your laptop. Okay? So if the window closed, please open the second attempt right away and upload the file. Okay? But if you use more than one attempt, just email me and let me know what's going on. Maybe your internet is not stable. So I just want to like check if everything's okay. Alright? So yeah, I said the number of attempts will be unlimited. So just keep open and more attempts to attach the file. Okay, so that is the quiz. The homework, the first homework, I saw many of you get 25 points. Except two of you didn't get 25 points. You know you can redo the problems again and again until you get perfect scores, right? So yeah, if you have questions, feel free to come to see me, ask me, okay? And all of you know that we have the sample homework solution, right? Do you think this sample homework solution is similar to your homework questions? Yeah, do you think it's similar? Yes? Okay, right. Yeah, you can use your first attempt, try it without looking at the solution. And your second attempt, you can look at the solution and figure out what's the way to solve that type of problems. Yes?
Wait, are the homework due dates different than the homework solution?
Homework solution is posted all the time.
Oh, okay.
The homework due date is the homework due date.
Okay, was the second homework due today?
No, Friday.
Okay, Friday.
So Friday this Friday you have homework 2 and your quiz 2. Oh, sorry, quiz 1. You better finish your homework before you take the quiz. Yeah. Because your quiz 1 cover homework 1 and homework 2 stuff. So yeah, I would say do your homework today. If you have questions, you can still have time to ask me on tomorrow, right? Or like on Friday. Okay? Yes. And make sure you understand every problem on your in-class notes and on your homework. Okay. All right, 3.2, continuity. So for many of the functions we look at in 3.1, do you remember how do we compute limit? We plug in a number and see what happens, right? If you get a nice number, it is a nice number, not something weird like 0/0, then that number is the limit. But if you get something like 0/0, that's not good. And it depends on the problems. Do you remember if we have rational functions, the numerator and denominator are polynomials, you factor, right? And you can cancel the bad guy, and then you can plug in a number again. If you have difference of square roots, you multiply by its conjugate, right? Conjugate, what's conjugate? It's a opposite side, so it's like sum of square roots, right, everybody? Because a plus b times a minus b is a square. minus b squared. That's why the square and square root cancel, right? The third type problem is when you see fractions, okay? If you see more than one like fractions, you want to combine into a single fraction and simplify it. Hopefully, in this case, you can see the background and cancel it. Okay, and then you can plug in the number again. So the process, when we plug in the number and the limit equals the function evaluate at that number, well, this concept is continuity. Okay, so continuity is related to the appearance of a graph. The function is continuous on an interval if its graph can be drawn without lifting your pencil from the paper. Right? If you draw something like this is continuous. But if you draw like something like this, has a hole there, then it's not continuous. Or if you draw something like this is not continuous. Right? Or you draw something like this, see, it's disconnected. So this is not continuous. So you have to draw it without lifting your pencil from the paper. And the formal definition of continuous at a point is limit x goes to a, f of x equals f of a. So this actually has three information. First information, unit f of a is defined. Okay, everybody? In this case, this point is not defined, right? You have a hole there that's not defined. So this is not allowed. So we need f of a is defined. Second, we need the limit exists. Remember, the limit exists if your left side of the limit and right side of the limit match, right? And exists, then you cannot say it goes to infinity or minus infinity, because infinity or minus infinity we consider does not exist, right? Yeah. And the third one, this limit exists equals to the number, and that number equals to the function evaluate at a. Okay, everybody? So we have this is defined. This exists. Remember, define or undefined, we describe the function. Exists or does not exist, we describe the limits. Right, everybody? So yeah, and the third one, we want them equal. And a function is continuous if it's continuous at all points in the domain. Okay, like line is continuous, right? X squared is continuous because you just draw it. It goes to infinity, right? X cubed is also continuous, right? And square root is like this. It's continuous in the domain, right? The domain is greater or equal to 0, okay? So the function is continuous in the domain. Okay? Even though the domain is not all real numbers, but on the domain from 0 to infinity, the square root of x is continuous. Okay? All right, keep going. So examples with discontinuity. So part A, this one is continuous. Let's see. Okay. Right, this one is continuous. The B is not continuous and it violates which condition? You have a hole there, open circle. Which condition does it violate? First one, f of 0 is not defined because there's an open circle. The point is missing. So this is not continuous and it violates condition 1. F of 0 is undefined. Okay, so when you say it's not continuous, you can actually go deeper. Which condition it violates? Okay, everybody? How about this? Do you see this solid dot here? So the function is defined, right? Does the limit exist? The limit, what's the limit?
Oh, that's one.
The limit is 1, right? Mm-hmm. dependence. Okay. So here, f of 0 equals f of 0. The function evaluated at 0 is 2. Okay? And where is f of 1? F of 1 is you plug in when the x is 1. So this is f of 1. So we're not talking about f of 1. We're talking about, see, the problem is at x is 0. Okay? We have the limit. See, the limit is not equal to 0. It's, the limit is when x approaching to 0. Do you see the y value approaching to 1? So the limit when x goes to 0 is 1, but the function f of 0 is 2. They are not equal. Okay, so we violate condition 3. So this is not continuous, and we violate condition 3. F of 0 is 2, but the limit x goes to 0, f of x equals 1. Is that okay, everybody? Okay, next one. This is not continuous. Okay. Is f of 0 defined? Yes. What's that? 1, right, everybody? You look at the solid circle or open circle, and then you know whether this is including endpoints, right? So f of 0 is 1. What's the limit?
0.
The limit 0? The left side limit is 0. The right side limit is 1. Are they the same? No. So limit does not exist. Okay, everybody? So evaluate number 2. Exactly. Okay, so evaluate number 2. The limit does not exist. Okay, everybody? And we know f of 0 is 1. So condition 1, no problem, is defined. But the condition 2, the limit does not exist. Okay, how about this? Is f of 0 defined? No. Do you see any point here? No. So also, does the limit exist? No, it goes to infinity, and infinity we consider that does not exist, right? So evaluate both condition 1 and condition 2. You know, f is not defined, limit does not exist. Then you cannot say they are equal. You have nothing there. So it's like you have a room, and then you can say, oh, this student do something. But if the room has no student, we cannot say that the student is doing something, right? If there's no student, what can you say? Yeah? So if it's f of a is not defined, the limit does not exist, you cannot mention they are equal. You have a number for it. Yes. So violate 1 and 2. Okay, so right, the limit does not exist and function is not defined. How about f? Is the function defined as 0? No. Right, everybody? It's no. The limit exists? No. Remember, alternating between two numbers? Limit does not exist. So this is also violate 1 and 2. Okay? So we have part A, continuous. But B, C, D, E, F, they're all discontinuous. And actually, all these pictures, we have different names for it. So discontinuity in part B and C are called removable discontinuity because we could remove them by redefining F at just the single points x equal to 0. Yes.
I have a question.
Sure.
Like, for f, isn't there a limit right here? But you say it doesn't have a limit.
Yeah, because you are oscillating between 1 and -1. Then the limit does not exist. If
They only have a vertical asymptote here.
we don't have a vertical asymptote. Vertical asymptote is when you are approaching to infinity or minus infinity. But here we're not approaching to infinity. You never go beyond 1.
So this piece right here.
This piece, the picture is not so good because usually you just get to shake it. The moon one. It will be all over the blue line, I would say. Yeah, it should not have a region there. But it's like this, so it's not defined because it's between -1 and 1. What number do you pick? Yes, you cannot pick 1. The -1 say, that's not fair. Why don't you pick me? Right? Yes. So B and C are called removable discontinuity because you just put the point here, then it's continuous, right? Here, I don't like this point. I put the point here, then they're continuous. So they're removable discontinuity, okay? And part D is called jump discontinuity. Kind of makes sense, right? You jump from here to here. The values jump. Okay? The jump discontinuity. And then this one is infinite discontinuity. Also makes sense. It goes to infinity or minus infinity. Right, everybody? The last one is called essential discontinuity. So if you see oscillating between two numbers, it's called essential discontinuity. Okay, so all of them have different names. Okay, so let me hide this and ask you, what do you call this? Essential discontinuity. This one? Jump. Right, everybody open your mouth. This one? Removable. This one? Infinite. Okay, good. All right, next, we have the table. It looks like a lot of things, but I can summarize in one sentence. That is all the functions we learned are continuous on their domain. Just remember this one sentence, okay? It means all of this. Okay? So that's why if you have f and g are continuous, the sum is continuous, the difference is continuous. You can multiply by a number or you can multiply them. Oh, but if you divide them, do you see if you divide them, when you talk about the domain, your denominator cannot be 0. Right, everybody? But still, the function is continuous on the domain. Your domain is just, you need to include the denominator not equal to 0. Okay, everybody? And also power functions. Polynomial is continuous for all x. Rational function is continuous when the denominator is not 0. Sine, cosine, domains everywhere, right? So continuous for all x. Tangent is this, a lot of copy of this, and you have a lot of vertical asymptotes. So, and also secant, up, down. The vertical asymptote, and it's also like the domain. The domain, x cannot be pi over 2 plus k pi. Right, everybody? So still continuous on the domain. And cotangent and cosecant also continues on their domain. The domain is x not equal to k pi. Okay? And exponential functions and logarithm functions are continuous in the domain. So all functions we learned are continuous on the domain. Okay? So to find the interval where the function continuous is the same thing to find their domain. Okay, everybody? Yes. Composite function, if G is continuous and F is continuous, and the composite is also continuous. Okay? All right. So let's do the following example. We find the K such that the function is continuous everywhere. Okay. Let's look at the top formula. Your X, you see X? you shift up a little bit. So it's still continuous. You see the first formula is continuous everywhere, right? And second formula is a polynomial. It's also continuous everywhere. So the only possibility a discontinuity might happen is when those two pieces met. Right, everybody? So you can have one piece like this, the other piece like this, then they're not continuous. Okay? But if you have both pieces touch each other, then it's continuous everywhere. Is that okay, everybody? So it's enough to just check when those two pieces met. In this case, they met at x equal to 0. And like example 2. What number do you check? 2. So 2 is where those two pieces met. Okay? All right, so let's see. Okay. Remember, continuous at a number, we need function is defined and the limit exists, right? So first of all, function is defined. So we check at the point 0. Okay? What's f of 0? Do you use the top formula or the bottom formula? Bottom, because the equal sign is here, right? At the bottom, we have 2 times 0 minus 3 squared. 9, yes, very good. Right, everybody? Minus 1 squared is positive 1. 3 squared is 9. Okay, everybody? Alright, and then we need to have the limits exist. So here, because we have two different pieces, we need to check the right-sided limit and the left-sided limit. Let's check the left side first, and let's check the right side. Okay. Left side. It means we use the top or the bottom formula. The top less than 0. Right? Everybody? Use the top one. So please make sure you have the limits every step as long as you still have x in the expression. Okay, so as long as you still have x in the expression, make sure you have the limits. Otherwise, in the exam, 1 point will be off. Okay, everybody? How many points? 1. Yes. Let's plug in 0. If you plug in 0, what happens to this term? 0. X is 0. And also side 0 is 0. 0 times 0, 0. So do you see we only left with k? By the way, k is just a constant. It's not a variable. It's a fixed number. Okay? The x is the variable. X is changing. Okay? So just treat the k as a number. So we get 0 plus k is k. And then the right side limit. Which formula do we use? The bottom one. So we put 2x minus 3 squared. And now we plug in 0. What happened? Yeah, if you plug in x is 0, you get 0 minus 3 squared, which is 9. Yes, everybody? You want the limits exist. So you want the left side limit and right side limits equal. So we set them equal. So you get if k equals 9, then you have the function value is 9 and the limit is also 9. Therefore, the function is continuous. Okay, so f is continuous. Okay, it's continuous at x is 0, but because of this guy, they're also continuous, so you get continuous everywhere. Okay, everybody? Mm-hmm. Okay, yes. So this is steps. You check the function value, and you check the left side of the limit, the right side of the limit, set them equal. And in this problem, it's very easy. You just get k equals to 9. But maybe some other complicated problems, you will get an equation, and you solve a k. You might have a quadratic equation. You might have a polynomial equation. It depends on the function. Okay, everybody? All right, let's do example 2. Okay, example 2. So do the same thing. What number do we check? 2. And which formula do we use? The bottom. So we plug in 2. We get e to the 2 minus 2 times k squared plus k times 2 plus 1. So far, so good. What's 2 minus 2? 0. What is e to the 0? 1. Yes. So we have 1 times k squared is k squared, right? Plus, how many k? 3k. Right, everybody? Yeah, it's okay. It's not a number. It's an expression with k. It's okay. It's just a constant. Right. All right. So keep going. The left side of the limit. Which formula do we use? The top or bottom? Top. So we have x squared minus 4 over x minus 2. Right, everybody? Okay. If you plug in 2, what's 2 squared? 4 minus 4, 0. 2 minus 2, 0. If you see 0 over 0, what do? Factor. There's a bad guy, right? How can you factor? How do you factor the numerator? Yeah, very good. Do you see the bad guy? X minus 2, it makes the numerator and denominator 0. So we cancel it. Okay, next we can plug in the number again. What do we get? 4. Right, everybody? See, here we use something we learned before in 3.1. Okay, good. Next one, x goes to 2 from the right. Which formula do we use? The bottom one, right, everybody? So write down the bottom formula. And do you see here? What we do is we plug in x is 2 into this formula, right? Which we already did. Yes, everybody? We already did it. Put the 2 inside this formula, which is k squared plus 3k. Right, everybody? So you don't have to copy this thing again. You directly just put k squared plus 3k here. Okay? So k squared plus 3k. Is everybody okay with that? Because usually when the problem gives you, and if one of the p's has the equal sign, then that formula is also equal to the function value. So you don't have to do it again. Okay? One of the p's will be equal to f of the 2. Okay? All right. So now what do we do? See? We set them equal. Oh, you see, now we get a equation. We get k squared plus 3k equals 4. Okay. I want everybody, how do you solve this? Okay, do it now. How do you solve this? Right. So and then you can number it. So 2 ways to do it. Move all the terms to one side. Here, factor it. Then use the quadrant. Yes. Right. If you see a quadratic equation, move all the terms on one side. So subtract 4 on both sides. Get k squared plus 3k minus 4 equals 0. There are two methods you can solve quadratic equation. Either use factoring or use quadratic formula. So factoring, how do you factor? Yes. And then you set each factor equal to 0. What's k? Yes. Right, everybody? So if k equals -4 or k equals 1, then f is continuous. Right, everybody? So this problem, you can factor it. In general, if you have a quadratic equation and you cannot factor it, you can use the quadratic formula. So, but you also want to make all the terms on the left-hand side. Okay, everybody, move all the terms to the left-hand side. Do you remember the quadratic formula? Square root of b squared plus minus 4ac over 2a. Yes. If you forgot the quadratic formula, write it down. Okay? So I don't promise you in the exam if your number will be super nice. It is possible that in the exam maybe your number is not so nice, you cannot factor it, and use the quadratic formula. Okay, everybody? All right. So now we did two examples of this kind. So you know the steps of solving this type of problems. You find the function evaluate at that point. You compute the left side of the limits. You compute the right side of the limits. And you set them equal. And you solve for k. Okay? All right. So next definition. A function is continuous from the left. Always say left continuous. If limit x goes to a from the left equals to f of a. So if we use picture, what's the picture look like? So you have a here. You want the left side of the limits equals to the function value. This is left continuous. It's continuous from the left. Is that okay, everybody? The left side limit equals to the function value. Okay, let me ask you. This guy is left continuous or right continuous? Left, because the endpoint is with the left piece, right, everybody? So right continuous will be something like you have a here, your your point equals to the right side of the limit. Is that okay, everybody? Mm-hmm. Yeah, now you can say a function is continuous on an interval I if it's continuous at all the points of I. If I contains its endpoints, then continuity means it's continuous from the left or continuous from the right at the endpoints. Okay, so if I randomly just draw some graphs like maybe like this. Something like this. Okay. Maybe crazy. Okay. Then here it's not continuous. Right, everybody? And then here is left continuous or right continuous? Left continuous. And then here is not continuous. So you can look at the picture and figure out left continuous or right continuous. Okay, now assume m and n are positive integers, and still all functions we learn are continuous on the domain, right? That's why if you have a square root, see, if m is an even number, then you have m roots. It's kind of like square roots. For square roots, you need the things inside the square root to be greater or equal to 0. So your domain changes. Okay? And still, all the functions we learn are continuous on the domain. Is that okay, everybody? Mm-hmm. Yes. Keep going. Okay. So this type of problem, find the values of x such that the functions are continuous. Because all functions we learn are continuous on the domain. But this problem is the same as to find the domain of the function. Do you agree, everybody? So this is the same as find the domain of the functions. And let me remind you, there are like 3 special functions with strict domain. First one, if you see square root, what do you need? Square root, the things inside the square root to be greater. Yeah. What's the second thing? If you see fractions, what do you need? If you see fraction, what do you need? The denominator not equal to 0, right? Do we care about the numerator? No. The numerator could be anything. The denominator cannot be 0. Okay, the third thing. Natural log. What do you need? Natural log greater than 0. Remember, the natural log looks like this. So your domain greater than 0. Okay? Your square root, what does your square root look like? This. So you can include a 0. Okay, everybody? Do you still remember this? We talked about this before when we talked about the domain. Yes. Keep those in mind. Okay, now look at our functions. Do you see square roots? Cube roots. What's the graph of cube roots? So cube root is the inverse function of x cubed. Right? This is x cubed. And the inverse function is you reflect over the x-axis. So cube root is like this. Right? So cube root, the domain is all real numbers. Right, everybody? Let me write it down. So this is x cubed. And when you find inverse function, you look at the line y equals x, and you flip it over. So this is cube root of x. But the domain is all real numbers. Therefore, all of this, exponential function, polynomial, sine, cube root, domain are real numbers. So this function is continuous for all real numbers. Okay, so f is continuous for all real numbers. Are you okay with this expression? This means belongs to. You know R is the set of real numbers? So X belongs to the real numbers. It's the same thing as saying f is continuous on, you use interval notation, then it's minus infinity to positive infinity. Okay, so you can answer like both ways. Okay, but I usually prefer the interval notation. Okay, everybody, use interval notation, please. Okay, part B. Do you see a square root? Part B. Yes. Do you see a square root? Part B. So what do we need? The thing inside the square root, which is what? 5x plus 4. What do we need? This guy to be greater than 0. Look at it carefully and tell me again. What do you need? Just greater than 0? Is also, it could be equal to 0. Okay, everybody? Yes. Okay, how about you guys take turns to answer my questions? Yes, Blaine, how do you solve for x? Minus 4. Yes. And because 5 is positive, do you change the inequality sign? No, yes, right. We only change the sign when we multiply or divide it by a negative number. So x is greater or equal to minus 4/5. Okay, Will. Do you see a fraction here? I mean the function f. Do you see any fraction? Do you see any denominator? No, so no denominator. Okay, so you check down the list. Square root? Yeah, we have square roots. Fractions? We don't have fractions, no denominator. Do you see Alan? Yes. What do you put here? So you put the things inside the ln, which is? We need, when we set up the inequality, don't put the ln in it. You just need the things inside the ln to be greater than 0. Okay? Yes, this is a really common mistake because I had students, like before I checked the homework, they like to put the square root of this greater equal to 0. Don't put the square root there. Okay? Or here, don't put the ln there because you mean different things. See, this is the ln, right? The domain is the things inside the ln is greater than 0. But if you put the ln here, what do you mean? You actually means you want to look at the p that is greater than 0. So you mean the things inside would be greater than 1. That's not what we want. Okay? So that's why when you set up the inequality, do you put the square root here? Do you put ln here? No. Just the things inside. Okay, everybody? Yeah. Good. Okay, so we set up. How do you solve for x? So it's inequality. How do you solve for x?
Oh, you plug
We plug in 0. Okay. If you plug in 0, do you see just get x greater than 0? It does not give you the x values. So think about it. How do you solve for x? You want to move all the other terms on the other side, right? And you only want to have x by itself on one side, okay? So what do? Yeah, move the 8, then we're like subtracting 8 on both sides, right? Okay, subtract 8 on both sides. We get minus 12x greater than minus 8. Dylan, what do you do next? Okay, everybody, if you divide it by negative 12, what happened? Flip the sign. It becomes less than. Yes, everybody? Inequality, you gotta be very careful. So we get x is less than Paige. Can you simplify this? Yeah, we can the plus sign cancel, right? If you divide it by 2, what's left? 8 divided by 2 is 4. 12 divided by 2? 6. Oh, can you simplify further? Yes. 2 over 3. Yes, 2 over 3. Okay, everybody? So, we're not done. Draw the real number line. Draw your inequality. X greater equal to minus 4/5. So, minus 4/5. Okay, Mackenzie, do we put a solid circle or open circle? Solid. And it's the left or the right side? Right, because it's greater equal. Okay, next number. 2/3. Gabby, open circle or solid circle? Open. Left or right? Left. Ooh, because we need to satisfy both conditions. So you're looking at where they intersect, the common region, right, everybody? So all we can say f is continuous on, what is the interval notation, Down J? Interval notation. Parentheses or brackets? Yes, good. Right, everybody? Okay, let's continue. Next class. And please remember to print out 3.3. Okay? So see you. And Friday we have homework 2 and quiz 1. Yes. Huh? The homework is missing 1.3? Yes. Which homework? Homework 2? Let's see. Do you remember like which problem? So which questions? No. Oh, okay. Attendance. Do I give attendance? Okay, yes, I do. So yeah, which question? Is that one? Homework 4? Yeah, homework 4. Yeah, evaluate the limits. Hi. So yeah, you plug in
What
XS2.
you plug it into?
Here or here?
But normally when you give it to us like that, you have like the equation of f of x.
Yeah, in this case, f of x is just x. So you plug in x as 2, then you just get 2. Exactly. Look at this one. You get a number. Do you have an x in it? Do you have an x in it? No, it's just 15. Yeah.
I just wanted to let you know Monday I didn't
Oh, okay. Can you also email me? Thank you.